Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to discuss this question 56 that was asked in JAM 2022 paper. At constant volume, 1 kilojoule of heat is transferred to 2 mole of an ideal gas at 1 atmosphere and 298 Kelvin. The final temperature of ideal gas is how much? So let us first write down the given data. 1 kilojoule of heat Q or heat is given to us. What is the heat given? 1.0 kilojoule. Now the value of R is in joules, so we can convert this into kilojoule into joule. So 1.0 into kilo means 10 raised to 3 joules, or I can write it as 1000 joules. Next, what is given is number of moles is given. Number of moles N is how much? 2 mole. And pressure is given 1 atmosphere, and initial temperature is given to us. I can write it as Ti, or initial temperature is how much? It is 298 Kelvin. What we have to find out is the TF, or we can say final temperature, is what we have to find out. Now, which formula we have to use here? Q is equal to NCV delta T. Why I have used CV? Because it is mentioned that it is at constant volume. Okay, so we have to substitute CV and delta T. This I can write it as NCV. Delta T is final temperature minus initial temperature. What is delta T? Delta T is change in temperature. Change in temperature. Now, for finding out the value of T final, what we need Ti. Initial temperature is given. Number of mole is given. Value of heat is given. What is not given is CV. Now, the question is, how do you find out the value of CV? So CV, since it is not given, ideal gas, we can consider which ideal gas? It will be monoatomic ideal gas. Okay, we can consider it is a monoatomic ideal gas. And for monoatomic ideal gas, we have to find out the value of CV is how much. So for that, we must know the value of gamma or adiabatic constant. Okay, what is the formula for that? 1 plus 2 by F. What is F? F is degree of freedom. F is degrees of freedom. Okay, for a monoatomic ideal gas, there are how many degrees of freedom? There are only, this monoatomic ideal gas can move in three different directions, either in X direction, Y direction, or Z direction. That is, there are three translational degrees of freedom. There are three translational degrees of freedom. So what is the value of F? F is 3. Okay, vibrational is 0 and rotational is also 0. So the total degree of freedom is how much? It is 3. So what we can do now, we can substitute in this value. What is gamma? Gamma is Cp by Cv is equal to 1 plus 2 by 3. Cross multiply, 3 ones are 3 plus 2, 5 by 3. So Cp by Cv is 5 by 3. Okay, Cp by Cv is 5 by 3. Let me erase this. So we got the value of gamma Cp by Cv is equal to 5 by 3. Now what we want? We want the value of Cv. We must know another relation, that is Cp minus Cv is equal to R. This is what this is called as Mayer's relation. Okay, using this Mayer's relation, we can find out the value of Cv. Okay, now what we can do? We want Cv. We don't want Cp. So I can write Cp is equal to 5 by 3 times Cv. What I've done, I've just brought Cv here. So Cp is 5 by 3 of Cv. So Cp is 5 by 3 into Cv minus Cv is equal to R. Cv I can take common, 5 by 3 minus 1 is equal to R. Cv cross multiply, 5 minus 3, 2 by 3 is equal to R. So what is Cv? Cv is 3 by 2 R, or I can write it as 1.5 R. Now it is easier. What we can do now, we can substitute and find the value of final temperature. N CV delta T, N CV delta T is T final minus T initial Q. Now I can substitute all the values. Q is how much? 1000 joule. There are 2 moles of an ideal gas into CV is how much? 1.5 into R. R is 8.314 joule per Kelvin per mole into final temperature. We have to find out. Initial temperature is 298 Kelvin. Now if you see the units, joule and joule get cancelled and mole inverse get cancelled. So final unit of temperature we will get in Kelvin. So what I can do? TF minus 298 is equal to 1000 divided by 2 into 1.5 into 8.314. Unit is Kelvin. So this, if I solve, final answer that I get is, if I solve this entire thing for TF, what I will get? TF I get is 338.1 Kelvin. 338.1 Kelvin. This is the final answer. And if you see the range that is given, that is how much? 338.0 to 338.2. Why I've rounded off to 1 decimal place? Because here it is mentioned that round off to 1 decimal place. So the actual answer that you get is 338.093. Okay, 09. So here it is 9. So I can add 1 to the previous digit. So that's how I have rounded off to 338.1. Okay, so which are the correct answers? If you write 338.0, then your answer is correct. If you write 338.1, then also you will get the credit. And if you write 338.2, then also you will get the credit. Only these three answers, if you write, you will get a credit of. This was how many mark question? It is a 2 mark question. I hope you have understood the solution. Thank you.